What's your name? Please type it in, then click OK. You made it! Hi. Care for a fly? I'm a freshwater frogonaut named Thaddeus Pole, but you can call me Tad. We'll be finding out a lot of cool stuff together. It's easy. If you get stuck or lost, just click on me. That's my motto. Click it. Repeat. Click it. What do you want to do? What do you want to explore first? See my ship's window? Pick a place, click it, and let's go.
Weather. The weather can change from one moment to the next. A warm sunny day can turn into a violent storm. Dark clouds form, high winds blow, and rain lashes the ground. In just a few minutes, however, sunny weather may return.
The sun. The sun is the main force for the world's weather. The heat of the sun's rays produces wind and evaporates water from the seas. Later, the evaporated water forms clouds and rain. The sun. The sun is the main force for the world's weather.
Air pressure. The Earth's atmosphere pushes on the Earth. This pressure is not the same everywhere. Cold air pushes harder than warm air, so cold air forms high-pressure areas in the atmosphere. Warm air forms areas of low pressure. Air is usually squeezed from areas of high pressure to areas of low pressure. Geography. Geography. The size and shape of areas of land and water also affects the weather. Air masses and fronts. Huge bodies of air, called air masses, form over land and sea. Air masses can contain warm, cold, moist, or dry air. They bring different kinds of weather as they move across water and land. When two air masses meet, they form a front. The weather changes when a front arrives. Cold air moves under warm air, bringing heavy rain that is followed by showers. Colder weather follows the cold front. Long spells of light rain occur as warm air moves above cold air. The weather clears and becomes warmer after the front passes. Cold fronts move faster than warm fronts. If a cold front catches up with a warm front, the cold air moves under the warm air and occludes it, or keeps it from reaching the ground. Rain falls along occluded fronts, but it is usually less severe than along warm or cold fronts.
Weather stations. Several thousand weather stations on land, ships, and airplanes measure weather conditions around the world. They record temperature, rainfall, wind speed and direction, air pressure, and humidity.
Balloons called radiosondes carry instruments high in the air to take measurements of temperature, air pressure, and humidity. When the balloon bursts, a parachute carries the instrument safely back to the ground.
Weather planes measure atmospheric conditions at various altitudes. When a dangerous storm such as a hurricane approaches, weather planes gather information so that scientists can figure out how big it is.
Weather satellites in space send pictures of clouds back to Earth. By studying clouds, meteorologists, scientists who study the weather, can watch developing storms. Weather satellites at observation stations on land, people measure temperature, air pressure, rainfall, wind speed, and other conditions every hour. Radar is used to detect storms.
Buoys collect information about the weather at sea and send it to communications satellites.
Weather buoys and balloons are released from ships to take measurements. Weather conditions over much of the ocean, however, are not monitored.
Air masses and fronts. Huge bodies of
Geography.
Mountains force ocean winds that blow toward them to move upward. As the air rises, it becomes cooler. Water droplets in the cooler air condense and form clouds that may dump rain or snow on the mountains. Oceans and other large bodies of water keep nearby land from becoming too hot or too cold. This happens because water absorbs and loses heat more slowly than land. During the summer, air over coastal land rises as it is warmed, and cool ocean breezes rush in to take its place. During the winter, heat from the water keeps coastal areas warm.
Far from the ocean, the plains get little rain. Strong, hot winds may blow down from the mountains and across them. Far from the ocean. Weather in cities is often warmer and wetter than in the countryside. Heaters, ovens, and factories produce heat, and materials such as brick, asphalt, and metal absorb it. In addition, many things people do, including driving cars and running factories, release tiny particles of liquids, gases, and solids into the air. Water vapor may condense around these particles and form clouds. Too many extra particles in the air can keep heat from escaping.
Air pressure. The Earth.
Regions of high pressure are called anticyclones or highs. Regions of low pressure are called cyclones or lows. Winds circle around highs and lows. The air spirals outward from highs and moves downward. Around lows, the air circles inward and rises. A barograph measures air pressure. This measurement is important in weather forecasting because high pressure often brings clear, dry weather. Low pressure brings wind and rain. The sun. The sun is the main force for the world's weather. The heat of the sun's rays produces wind and evaporates water from the seas. Later, the evaporated water forms clouds and rain. The sun's heat keeps winds constantly circulating over the surface of the earth.
An instrument called a sunshine recorder measures hours of sunshine during a day. A glass ball focuses the sun's rays onto a piece of cardboard. The strong light rays burn. An instrument called weather. The weather can change from.
The word weather describes conditions, such as rain, wind, and sunshine that occur during a short period of time in a particular place.
Climate is the overall pattern of weather in a region. The weather in a place can change day to day, but its climate remains the same. This beach is in a region with a sunny climate, even though it may have rained yesterday.
Forecasting the weather. At weather stations around the world, computers draw charts that show air pressure and fronts over a large region. Meteorologists use the charts to predict the weather for the next few days. They produce weather reports for television, newspapers, ships, and planes.
Lines called isobars connect regions that have the same atmospheric pressure.
Isobars of rising pressure indicate a high where there is calm weather.
Blue triangles show a cold front moving in.
Red semicircles show a warm front moving in.
Do you want to know more? Here are some related topics.
Three, two, one.
Earth. Whether you live in a big apartment building or a house in the country, your home in the universe is still the same. A large block of rock spinning through space. This is the Earth, one of the 9 planets that circle the Sun.
The Earth is the only place we know of that can support life. It has oxygen in its atmosphere and water in its oceans. Of all of the planets in the solar system, the Earth is at just the right distance from the Sun to be neither too hot nor too cold. The Earth is the only The Earth is the Earth
Outside. If you were in space, you would see the Earth as a blue and brown ball covered by swirling masses of clouds. The Earth is not a perfect sphere, however. It is bigger around the equator than it is around the poles, and it also bulges out very slightly below the equator, giving it a shape more like a pear than a sphere.
Land covers about 29% of the Earth's surface. Most of the land is broken into large pieces called continents. Smaller pieces of land are called islands. The tallest point of land on Earth is the peak of Mount Everest, 29,028 feet, 8,848 meters above sea level. Land covers about
71% of the Earth's surface is covered with water. The deepest water is in the Mariana Trench in the Pacific Ocean, where the water measures 36,198 feet, 11,033 meters. Water helps keep the Earth at a temperature that can support life. Clouds float in a layer of air that surrounds the Earth. This layer, called the atmosphere, contains mostly nitrogen and oxygen gases. The atmosphere shields the Earth from harmful rays coming from the sun. It also keeps the Earth from becoming too hot or too cold. Clouds float inside. No one has ever been to the center of the Earth. Still, we know that the Earth is made of layers of rock and metal. Some layers are solid and some are liquid. Geologists, scientists who study the Earth, discovered these layers by looking at how earthquake waves travel through the Earth.
The heat from inside of the Earth is a source of safe, clean energy called geothermal energy. Hot rocks lie close to the surface in Iceland, Italy, and other parts of the world. The rocks heat underground water and often make it boil into steam. Wells dug down to these rocks bring up the steam and hot water, which are used to make electricity and to heat buildings.
Crust. The layer of rock at the surface of the Earth is called the crust. It is up to 25 miles, 40 kilometers deep beneath the continents, but as little as 5 miles, 8 kilometers deep under the oceans.
Mantle. Under the crust lies the mantle, a layer of solid rock about 1,800 miles, 2,900 kilometers thick. The temperature rises to 8,000 degrees Fahrenheit, 4,400 degrees Celsius, at the bottom of the mantle, but high pressure keeps the rock solid. Outer core. The outer core lies below the mantle. It is about 1,200 miles, 2,000 kilometers thick. Temperature is around 11,000 degrees Fahrenheit, 6,100 degrees Celsius. Keep the rock, a mixture of iron and nickel, liquid. Some of this liquid rock rises to the surface of the Earth through volcanoes.
Inner core. The center of the Earth is a ball of solid iron and nickel. It is about 1,712 miles, 2,740 kilometers across, and has a temperature of about 13,000 degrees Fahrenheit, 7,000 degrees Celsius. The high temperatures are caused by rocks breaking down under pressure.
Spinning. Although you can't feel it, the Earth is always moving. It spins rapidly in 3 ways. It rotates like a top, it makes a big circle called an orbit around the Sun, and, as part of our solar system, the Earth spins around the Milky Way galaxy.
It takes 23 hours, 56 minutes, and 4.09 seconds for the Earth to rotate once. This is rounded off to 24 hours and called a day. The Earth's orbit is 595 million miles long. It takes the Earth 365 days, 6 hours, 9 minutes, and 9.54 seconds to complete one orbit. This is rounded off to 365 days and called a year. Every 4 years, we have a leap year, when a day is added to the calendar to make up the extra 6 hours. The movement of the Earth around the Sun creates the seasons. The Sun always shines directly on the Earth's equator. Seasons occur in places north and south of the equator because the Earth is tilted. When the northern hemisphere is tilted toward the Sun, people who live there have summer and spring. When it is tilted away from the Sun, they have fall and winter. Birth of the Earth. Scientists have figured out that the Earth is about 4.6 billion years old. Some moon rocks and meteorites, pieces of rock that fall to Earth from space, are the same age. This suggests that the whole solar system, the Sun, the Earth, and the rest of the planets, formed at the same time.
About 3.5 billion years ago, very simple living things appeared on Earth. Some of these living things produced oxygen, which built up in the atmosphere. The hardened rock of the Earth's surface, which had formed one supercontinent, broke up into the 7 continents, and the Earth took on the form it has today. It took about 100 million years for the Earth's crust to cool and become solid. Once the crust was cooled, volcanoes shot up liquid rock and gas from deep inside. The gases cooled quickly. They formed the atmosphere and filled the low places on the Earth's surface with water.
The Earth became hot as the rock particles crashed into one another. The surface was liquid and the young Earth glowed red hot. Radioactivity in the rocks caused more heat and the whole planet melted. Liquid iron sank to the center of the Earth while the lighter rocks floated above.
Scientists believe that the Earth formed from a huge cloud of gas and dust in space. The Sun may have formed when the center of this cloud contracted or shrank. Other parts of the cloud then came together in spinning clumps of dust and gas. These clumps were the beginning of Earth and the other planets. The clumps pulled rock particles toward them as they spun.
Do you want to know more? Here are some related topics. What do you want to find?
Climates. What is it like outside where you live? Is it warm most of the time? Does it rain a lot? Are there usually clouds in the sky? Your answers to these questions describe the climate of the area you live in. Charts, like the ones you see here, are often used to describe the climate of an area. How hot it is and how much it rains may change from day to day and from month to month, but the pattern stays the same overall from one year to another. The charts tell you that the antelope in the pictures live in a warm place where there are marked wet and dry seasons.
Climate is not the same as weather. Weather can change within minutes. Climate describes a region's weather over a long period of time. Climate is not the same as weather.
Climate zones. Climatologists, people who study climate, have identified several types of climates. Which of the cities below has a climate most like your home?
Greenland has 2 climate zones that can only be described as cold. The coastal regions have a polar climate that is always cold. Central Greenland has an ice-cap climate that is always freezing. It never rains in an ice-cap climate, but it does snow.
The city of Anchorage in the lower half of Alaska lies in a subarctic climate zone. Anchorage has short, cool summers and long, cold winters.
Much of Western Europe, including England, has an oceanic, moist climate. The weather is mild, with warm summers and cool winters. Rain is common throughout the year.
The central United States and Central Africa have the same climate, steppe. Steppe areas are much like desert climates in that they have periods of both hot and cold, even in the same day. Steppes, however, get a little more rain than deserts.
Bordering the Mediterranean Sea, Italy has a climate called subtropical dry summer. It has hot, dry summers and rainy winters.
The top half of Japan has a climate called continental moist. Plenty of rain falls throughout the cool summers and cold winters.
Mexico City, one of the world's largest cities, lies in the highlands climate. A highlands climate is cooler and has more rain than the areas around it because the land is higher. You might be surprised to find out that a desert is not always hot. The country of Egypt has a desert climate. It has little rain, but it has periods of both hot and cold. Most of India has a tropical wet and dry climate. It is hot all year, with alternating periods of dryness and heavy rain. In places like Singapore, it is very hot and wet all year. Singapore has a tropical wet climate.
Sydney, Australia has a subtropical moist climate. Rain falls throughout both the warm summers and the cool winters. What affects climate? Why is it hot in Brazil and cold in Antarctica? Why are climates different all over the world? A region's climate depends on many things. Can you guess what some of them are by looking at these pictures? Click on each to get an answer.
Where would we be without wind? Wind brings warmer, cool, moist or dry air to a region. Some winds, called prevailing winds, blow all year round. These winds help create the climates of many places.
If you look at the Earth's climate zones, you can see that a region's climate is affected by how close it is to the equator. The sun's rays warm the equator directly from above, making the tropics hot year-round. Away from the equator, the sun's rays are less direct, and climates are cooler, with big differences between summer and winter temperatures.
Brr. If you've ever gone swimming in the ocean, you may know what it feels like to swim into a cold current. Ocean currents can be warm or cold. The water warms or cools the air, which then blows over the land. The Gulf Stream is a warm current that flows across the Atlantic Ocean from the Gulf of Mexico to the shores of Western Europe. There, it warms the air and the winter weather is mild.
Did you know that it's a lot colder at the top of a mountain than at the bottom? Altitude, how high up a place is, affects climate, and so do other features of the landscape. Oceans or other large bodies of water can keep areas near the coast from getting very hot or cold. Mountains may keep wind and rain from reaching inland plains.
How does climate affect you? Do you have to wear a jacket when you go outside? What are the buildings around you made of? What plants and animals live near you? Climate has a lot to do with the way you live.
The type of shelter you live in depends a lot on the climate. If you lived in Swaziland in Africa, you might live in a house made of grasses. Because the weather is always warm, you would not need heavy walls or glass windows. You would need a roof to keep the rain off, however, since it rains all year round.
The type of climate you live in determines the type of trees and other plants that grow around you. Oak trees grow in places with mild climates. Spruce trees, however, are more common in areas with short summers and harsh winters. A squirrel may be a normal sight for you, but a penguin is probably not. Penguins are among the few creatures that can live in the polar climate of Antarctica. Other animals, including squirrels, are better suited to milder environments.
Whether you realize it or not, the climate tells you what to wear. If you lived on the island of Bora Bora, it would never get cold enough to wear a coat or a pair of jeans, even if these were your favorite clothing.
Seasons. In most places in the United States, it is hotter during the summer and colder during the winter. Seasons are times in the year when the climate changes.
Not every place on Earth has sunny summers and freezing winters. In some places it's hot all the time, but there is a dry season and a rainy season.
The sun's rays do not hit the Earth the same way year-round. During part of the year, the Earth is tilted so that the top part of it, or northern hemisphere, is nearer to the sun than the lower part, or southern hemisphere. This is when the countries in the northern hemisphere, including the United States, have summer. The sun's rays do not hit the Earth the same way year-round. During part of the year, the Earth is tilted so that the top part of it, or northern hemisphere, is nearer to the sun than the lower part, or southern hemisphere. This is when the countries in the northern hemisphere, including the United States, have summer. During another part of the year, the Earth is tilted so the southern hemisphere is closer to the sun than the northern hemisphere. It is winter in the United States, but in Australia it is the middle of summer. During another part of the year, the Earth is tilted so the southern hemisphere is closer to the sun than the northern hemisphere. It is winter in the United States, but in Australia it is the middle of summer.
Not every place on Earth has sunny summers and freezing winters. In some places it's hot all the time, but there is a dry season and a rainy season.
Changing climates. Some big climate changes, such as ice ages, happen over thousands of years. Other big changes, however, can happen within a few years.
Erupting volcanoes often send huge clouds of dust up into the air. The wind can spread the clouds thousands of miles, blocking out the sun and lowering temperatures in many places. Wind patterns over the Earth sometimes change. When this happens, regions that usually get some rain may get none for years. This is called a drought. Severe droughts have caused millions of people to die of hunger, thirst, and poverty.
Today, scientists worry about the greenhouse effect, the gradual warming of the Earth's climate. Like a huge greenhouse, the Earth's atmosphere traps some of the heat that comes from the sun. This is normal, and it keeps the Earth warm enough for plants and animals to live. Pollution in the air, however, traps even more heat. If the Earth becomes too warm, these same plants and animals may not be able to survive.
Constellations. Ancient sky watchers noticed that stars form fixed patterns in the sky. They imagined that the patterns were pictures and gave them names. Today, astronomers use 88 of these star pictures to divide up the night sky. These pictures are called constellations. You might know the 7 brightest stars in this group as the Big Dipper, the Plow, or the Wagon. The Big Dipper is part of a larger group of stars that astronomers call Ursa Major, the Big Bear, as ancient people did. Use your imagination to connect the stars. Do you see a bear? If not, what would you call this constellation?
Seeing stars. The best way to learn about constellations is to see them. You can see constellations without a telescope, but if you're in a city, streetlights and buildings often get in the way, so it's best to star watch in the country. Take a good star chart with you and see how many constellations you can find.
Even out in the country, you'll be able to see only some of the constellations. The Earth is constantly moving around the sun, so different stars are visible at different times of the year. A star chart shows you which stars might be visible in your area during each season.
People who live in the northern hemisphere can only see the stars above the northern part of the Earth. Ancient people named most of the constellations in the northern sky. They gave the names of animals and people from myths.
People who live in the southern hemisphere can only see stars that are above the southern part of the Earth. The European explorers who first viewed the southern constellations gave them names of scientific instruments such as the triangle and the compass.
Zodiac. More than 2,000 years ago, star watchers in Egypt noticed that 12 constellations lay on the path the sun appeared to take through the sky. Later, Greeks called these constellations the zodiac.
Many Egyptians believed in astrology, the idea that stars and planets affect life on Earth. When they saw that the sun seemed to pass through each sign, constellation of the zodiac at the same time every year, they thought that a person must be affected by the sign the sun was in when they were born. Click on each constellation to find out when the sun passed through that sign.
Pisces, the fishes, February 19th to March 20th.
Aquarius, the water bearer, January 20th through February 18th. Capricorn, the goat, December 22nd through January 19th. Sagittarius, the archer, November 22nd through December 21st.
Scorpio, the scorpion, October 23rd to November 21st.
Libra, the scales, September 23rd through October 22nd.
Virgo, the virgin, August 23rd to September 22nd.
Leo, the lion, July 23rd through August 22nd. Cancer, the crab, June 21st through July 22nd. Gemini, the twins, May 21st through June 20th. Taurus, the bull, April 20th through May 20th.
Aries, the ram, March 21st to April 19th. Pisces, the fishes, February 19th to March 20th.
Star stories. Of the 88 constellations, you can probably find one you especially like to look for. You can also find great stories and legends about almost every one. The Greeks named the northern constellations after many of their favorite heroes and heroines.
Cetus was a sea monster sent by Poseidon to punish Cassiopeia for her vanity. Cetus was supposed to kill Andromeda, but he was killed by Perseus before he had a chance. Andromeda was the beautiful daughter of Cassiopeia and Cepheus. Poseidon demanded that she be chained to a rock to stop the sea monster Cetus from destroying Ethiopia. However, Andromeda was rescued by Perseus.
Perseus was son of the princess Danae and Zeus, ruler of the Greek gods. Perseus grew up on an island. The king of the island sent Perseus to get the head of Medusa, a monster whose glance turned a person to stone. Perseus succeeded, but on his way back to the island, he found Andromeda chained to a rock and about to be killed by Cetus. Perseus saved Andromeda by showing Medusa's head to Cetus. Perseus then took Andromeda home with him to be his wife.
Cassiopeia was queen of Ethiopia. She thought she was more beautiful than the water nymphs. As punishment for her vanity, Poseidon, the god of the sea, sent a sea monster to attack her country. Cassiopeia is pictured on her throne. Cepheus was king of Ethiopia and was Cassiopeia's husband and Andromeda's father.
Stars. The sky is full of billions of objects. Most of the objects you see are stars.
A shooting star is actually a meteor. A meteor is a chunk of matter falling through Earth's atmosphere. As a meteor falls, it rubs against the molecules of the atmosphere. This heats the meteor until it burns and gives off glowing gases that people can see. A comet looks like a star with a long tail. Stars look like tiny pinholes of light, but they are actually very large. Stars look small because they are far away. The Sun is the star closest to Earth. It is about 93 million miles, 150 million kilometers away.
This is a planet. A planet doesn't twinkle like a star does. These shining lights move rapidly across the sky because they are attached to an airplane.
Artificial satellites that have been put in orbit by scientists may appear to be planets. Most satellites rotate with Earth. Birth of a star. Stars are born from great clouds of gas, mostly hydrogen, and dust. Gravity pulls the dust and gas together. The energy of pulling causes the star to heat up and glow.
Dark spots in a gas cloud are believed to be new stars. The stars stay dark until the temperature inside them is hot enough to cause a nuclear reaction. In this reaction, hydrogen atoms change to helium atoms.
Twinkle, twinkle, little star, how I wonder what you are. Hydrogen and helium, burning brightly like the sun. Twinkle, twinkle, little star, now I know just what you are.
The clouds of dust and gas that form stars are all over the universe. They glow when light from nearby stars reflects off the dust.
Twinkle, twinkle, little star, how I wonder what you are. Hydrogen and helium, burning brightly like the sun. Twinkle, twinkle, little star, now I know just what you are.
Color. If you look into the night sky, you may see stars of different colors. The color of a star depends on its temperature. Although people often say that things burn red hot or freeze blue with cold, star colors mean just the opposite. Blue stars are the hottest stars. Their surfaces reach 50,000 degrees Fahrenheit, 28,000 degrees Celsius. Yellow stars like the sun are medium temperature, about 9,932 degrees Fahrenheit, 5,500 degrees Celsius at the surface. If you remember that water boils at 212 degrees Fahrenheit, 100 degrees Celsius, you might think that the sun's medium temperature is pretty hot.
Red stars are cool as far as stars go. Some are less than 5,000 degrees Fahrenheit, 2,800 degrees Celsius at the surface.
Brightness. From Earth, some stars look brighter than others. The brightness of a star depends on its distance from Earth, its mass, and its temperature. Brighter stars are either closer to Earth, heavier than other stars, or hotter than other stars.
The bright star near the top left in this picture is called Betelgeuse. Betelgeuse appears brighter than many stars because it's closer to Earth than they are. Betelgeuse is about 600 light years away from Earth.
The largest stars are called supergiants. They appear very bright because they are so big. Rigel is 3 times farther away from Earth than Betelgeuse. Rigel looks brighter because it's much hotter than Betelgeuse.
Connecting the stars. When seen from Earth, stars look like they stay in the same order in the sky. Ancient people made pictures with the stars to help identify them. These connect-the-star pictures are called constellations. Can you find a well-known constellation in this picture? Try connecting the stars when you think you've found it.
Congratulations! You've made the Big Dipper.
Galaxies. Stars are naturally arranged into huge groups called galaxies. Galaxies can have many shapes. A ball-shaped galaxy is called elliptical. Earth is part of a spiral galaxy called the Milky Way. Other galaxies have no particular shape. This is what the Milky Way looks like from space. It is about 100,000 light years across. Earth is located on one arm of the Milky Way, right about where the red circle is in this photo. If you look into the sky on a clear, dark night, you may be able to see a cloudy band of stars. These are other stars in the Milky Way.
Death of a star. Stars live a very long time compared to people. However, they do not live forever. Stars die when they run out of gas to burn.
A regular star like the Sun lives around 10 billion years. Then it swells to become a red giant before it collapses.
When a red giant collapses, it leaves behind a shrunken star called a white dwarf. A white dwarf is still very hot and shines.
Scientists think that a white dwarf becomes a black dwarf when it cools. No one has ever seen a black dwarf. There hasn't been enough time since the beginning of our galaxy for any black dwarfs to appear. Large stars die quickly. After just a few million years, a massive star grows into a red supergiant and then collapses.
A massive star may leave a small heavy star called a pulsar after it collapses. The pulsar spins around sending out light.
Black holes may form when a red supergiant collapses. The supergiant becomes so small and so strong that it sucks in matter and light, making a black hole. Black holes may form when a red supergiant collapses. The supergiant becomes so small and so strong that it sucks in matter and light, making a black hole.
Sun. The Sun is the center of our solar system. Compared to the planets, it is huge, with a gravitational pull strong enough to keep the planets from flying off into space. In the universe, however, the Sun is just an average star. It is part of a galaxy or cluster of stars called the Milky Way. Can you find the Sun in this circle? Probably not. It's too small to see. The Sun looks large from Earth because it is closer to Earth than any other star. The next closest star, Proxima Centauri, is 4.3 light-years away. Light can travel about 186,000 miles, 310,000 kilometers per second. A light-year is the distance light can travel in a year. Light travels from the Sun to Earth in about 8 minutes.
In the same way the planets in our solar system revolve around the Sun revolves around the center of the galaxy. The Sun spins around the Milky Way galaxy once every 225 million years. Sun facts. The Sun is a ball of gas that is 109 times wider than the Earth. It takes up about 1,300,000 times as much space as the Earth, and is about 333,000 times as heavy. The very center of the Sun is called the core. It is about 221,600 miles, 350,000 kilometers wide. The core is where the Sun's energy is produced. The temperature of the core is about 27 million degrees Fahrenheit, 15 million degrees Celsius. The convection zone surrounds the radiative zone. The gases here are too cloudy for energy to radiate. Instead, the energy creates violent motions called convection that carry energy to the surface. The temperature by this point has decreased to 2 million degrees Fahrenheit, 1,100,000 degrees Celsius.
Just outside the core is the radiative zone. It is called the radiative zone because it transports or radiates heat outward. The temperature here is about 4,500,000 degrees Fahrenheit, 2,500,000 degrees Celsius. Just outside the core,
the Sun's surface is called the photosphere. It is about 340 miles, 547 kilometers thick. The photosphere gives off the sun's energy in the form of heat and light. It has a temperature of about 10,000 degrees Fahrenheit, 5,500 degrees Celsius.
The corona can only be seen during a solar eclipse, when the moon blocks the light that comes from the center of the sun.
Solar storms. People can't look directly at the sun, even through sunglasses, without harming their eyes. However, scientists have figured out how to look at the surface of the sun through a special telescope. They see amazing storms that shoot out fire thousands of miles from the sun.
Dark areas on the surface of the sun are called sunspots. Sunspots are cooler than other parts of the sun's surface. They last for a few months or less, but they cause violent storms above the sun's surface. This X-ray photograph of the sun shows a flare, one of the many violent reactions on the sun's surface. Flares are huge explosions that send fire streaming up into space. Some flares produce auroras, colored lights in the sky above the Earth's poles. Flares also create magnetic storms, which cause power failures and interfere with radio waves.
Solar eclipse. When the moon passes between the Earth and the sun is hidden. Broad daylight turns into blackest night for a few minutes in some places on Earth. This is called a solar eclipse. A solar eclipse happens about once every 18 years.
Solar eclipses have fascinated people from the beginning of time. Ancient people thought the sun gods were angry when there was a solar eclipse. What would you think if everything went black in the middle of the afternoon?
Partial solar eclipses are seen from the penumbra, the outer part of the moon's shadow. Here, part of the sun can still be seen.
A total solar eclipse occurs at places on the Earth where the sun appears to be completely hidden. This is where the center of the moon's shadow, called the umbra, falls on the Earth.
Life support. All of the Earth's energy, except nuclear energy, comes originally from the sun. That means that all life on Earth depends on the sun.
The Earth's atmosphere traps the heat of the sun, making the Earth a warm place where life can exist.
The sun's heat keeps the Earth warm enough for water to stay in liquid form.
Coal and oil were formed millions of years ago from plants and animals. When we burn these fuels, we release the sun's energy.
Animals capture the sun's energy by eating plants and other animals. Animals capture the sun's energy by eating plants and other animals.
Light energy from the sun is absorbed by plants. The plants use sunlight and carbon dioxide to make food.
Animals capture the sun's energy by eating plants and other animals.
People can capture the sun's energy directly in several ways. Many people use the sun's heat to warm air and water in their homes. Electronic devices called solar cells provide power for satellites and make electricity in experimental houses and cars. Solar power plants use large mirrors to focus the sun's rays on water pipes. When the water boils, it makes steam. The steam turns turbines in the power plant and creates electricity.
Sunburn. Have you ever been sunburned? The invisible or ultraviolet light of the sun shines on the earth all the time, even on cloudy days. Everything, including the cells of your body, absorbs it. Too much ultraviolet light can actually burn the cells of your skin. This is both painful and dangerous.
Sunburn can happen quickly. This person's skin has been burned to death. The outermost layer of skin has actually been killed by the sun's rays. Sunburn hurts, but after several days it peels off. Some burns are so bad that the sunburned person must go to a hospital. Too much time in the sun can also cause skin cancer.
Covering up is one of the best ways to prevent sunburn. A hat helps protect your head. Have someone help you put sunscreen over every part of you that isn't covered. You should put sunscreen on again every 1 or 2 hours, especially after swimming or sweating. The sun's burning rays are strongest between 10 o'clock in the morning and 2 o'clock in the afternoon, so be especially careful if you're outside during this time.
A brown pigment called melanin gives your skin its color and helps protect it from the sun. Dark skin has more melanin than pale skin does. People with dark skin don't sunburn as easily as people with lighter skin.
Story of the sun. Right now, the sun is in the middle of its life. It is an ordinary small yellow star.
The sun formed about 4.5 billion years ago, when gravity pulled a cloud of gas and dust together. As the cloud shrank, its center got so hot that hydrogen atoms began to combine. This is called a thermonuclear reaction. The sun is made up mostly of hydrogen, so thermonuclear reactions continue to send heat and light from inside the sun to its surface and out into space. This outward force balances the inward pull of gravity.
Scientists believe the sun will keep burning hydrogen like it is now for about another 5 billion years. At that point, they think it will expand to form a red giant. In the process, it will swallow the planet Mercury and give off so much heat that any life on Venus, Earth, and Mars will die. Scientists believe the sun will keep burning hydrogen like it is now for about another 5 billion years. At that point, they think it will expand to form a red giant. In the process, it will swallow the planet Mercury and give off so much heat that any life on Venus, Earth, and Mars will die.
After about 500 million years, the sun will shrink into a white dwarf, about the size of the Earth. It will then slowly cool for several billion years. After about 500 million years, the sun will shrink into a white dwarf, about the size of the Earth. It will then slowly cool for several billion years. After
Sun worshippers. Today, a person who likes to lie in the sun is sometimes called a sun worshipper. In ancient times, however, people really did worship the sun. Egyptians, Greeks, and many other people thought the sun was a god.
Ancient people had many stories to explain the movement and characteristics of the sun. One belief was that the sun was carried across the sky in a chariot. This painting by Italian artist Guido Reni shows Phoebus, the ancient Greek god of the sun, crossing the sky in a chariot. In front of the chariot is Aurora, goddess of the dawn.
Mercury now is the one closest to the shining sun. Venus, Earth, and then comes Mars, orbiting that burning star. Jupiter is next to them, largest in the solar system. Saturn keeps on orbiting, see how the rings keep circling. Uranus looks blue and green, it's cold at minus 353 degrees. Neptune is the bluish one, its atmosphere is hydrogen. Pluto is the furthest out, the smallest planet, there's no doubt. 9 planets orbiting the sun make up our solar system.
Planets. Did you know that there are 9 huge ball-shaped objects moving around the sun at this very moment? Did you know that you're on one of them? They're the planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto.
The largest planets have rings of dust and rock around them.
Saturn and Jupiter are usually easy to see in the night sky. Even to the naked eye, they look large and yellowish. Mars looks red, and Venus is especially bright. However, if you could see any of these planets up close, you would see that they don't give off light of their own. Planets appear to shine because they reflect light and heat given off by stars.
Earth isn't the only planet with a moon. Moons are satellites, objects that orbit planets or stars. Saturn has at least 18 moons.
Thousands of tiny planets, called asteroids, are found in the belt between Mars and Jupiter. Most of them are lumps of rock and metal just a few miles in diameter.
The sun is a star, a vast ball of hot gas, far larger than any of the planets. The 4 planets closest to the sun are called the terrestrial planets. These planets have rocky surfaces. The larger planets, Jupiter, Saturn, and Neptune, are made mostly or entirely of gas.
We have incredible pictures of the planets and their moons because space probes have flown to all the planets except Pluto. Voyager 2 was one of the most successful probes. It traveled for more than a decade, photographing the planets. In 1990, it made its way out of the solar system.
Solar system. Our solar system contains the sun and everything that revolves around it, including asteroids, comets, meteoroids, gas and dust, and the planets and their moons. Each planet moves in an elliptical, oval-shaped orbit. The planets all travel in the same direction, and they spin as they move.
Mercury. Mercury is the closest planet to the sun. Its surface is mostly dry and rocky, with craters like our moons. Temperatures on Mercury can reach 950 degrees Fahrenheit, 510 degrees Celsius in the day, but fall to minus 346 degrees Fahrenheit, minus 210 degrees Celsius at night. Mercury was first seen up close by the space probe Mariner 10 in 1974. Mercury is about 2/5 the size of Earth, and it spins at a speed of only 6 miles per hour, 10 kilometers per hour. At this rate, it takes 59 Earth days for the sun to rise and set on Mercury.
Venus. Clouds of poisonous gases and acid cover the surface of Venus. These clouds come from constant volcanic eruptions. They trap the sun's heat, making Venus the hottest planet in the solar system. The surface of Venus is hot enough to melt lead.
Venus is named for the Roman goddess of love. It is considered Earth's twin because the two planets are almost the same size. Size is about the only thing the two planets have in common, however. Venus even rotates the opposite way. That means that the sun rises in the west on Venus. Earth. As far as scientists can tell, Earth is the only planet in the solar system with drifting continents, water on its surface, and living beings. Liquid water and the air trapped in Earth's atmosphere make life possible on our planet. Earth's position in the solar system is perfect for life. If Earth were as close to the sun as Venus is, all of its water would evaporate. If it were much farther away, all of its water would freeze.
Mars. Mars is the mysterious red planet. On Mars, temperatures stay below minus 6 degrees Fahrenheit, minus 21 degrees Celsius. Racing winds stir up enough dust to cover the planet and carve strange hills and formations into its rocky surface. However, Mars is the one planet besides Earth where scientists believe life could exist. One of the most interesting things about Mars is its face. Eroded by the wind, one of the hills on Mars looks like a human face when seen through a telescope. In 1976, 2 Viking space probes landed on Mars. Through these probes, scientists learned about the weather, earthquake activity, and the chemical makeup of Mars.
Jupiter. Jupiter was named for the Roman king of the gods. It is the largest planet in the solar system. In fact, Jupiter is so massive that some astronomers call it a brown dwarf rather than a planet. A brown dwarf is a body that is between a star and a planet in size.
Jupiter's most well-known feature is the giant red spot. The spot is 3 times as wide as Earth. The giant red spot is a huge storm that has lasted for hundreds of years.
Saturn. Saturn is made mostly of gas. In fact, it would float on water if there were an ocean big enough to hold it. Saturn is also the most flattened planet. It spins so fast that its center bulges out.
Saturn has 7 major rings, and perhaps thousands of smaller ones. From information collected by the Pioneer and Voyager spacecraft, scientists learned that the rings are mostly clumps of ice-covered rock about the size of snowballs. Scientists are not sure how the rings form, but they may be the remains of an icy moon that broke apart. Of the 18 moons known to circle Saturn, Titan is the largest. Scientists think Titan is much like the early Earth, before life developed.
Uranus. Uranus looks blue-green because of the gases and water that cover the planet. We can't see them very well, but Uranus has 11 rings around it. The rings are hard to see because they are made of black chunks of matter.
Uranus is the only tilted planet in our solar system. In 1986, the Voyager 2 spacecraft passed by Uranus and discovered that the tilt may have been caused by a collision with an object the size of a planet. Voyager 2 also found 15 moons circling Uranus.
Neptune. From far away, Neptune looks blue, like Earth. It was named for the ancient Roman god of the oceans because early astronomers thought the planet was covered with water. Actually, Neptune is blue because of the gases that make up its surface. Neptune has no solid ground.
Neptune is the windiest planet. Dark spots on the planet are huge storms, with winds blowing up to 1,200 miles per hour, 2,000 kilometers per hour. Like the other large planets, Neptune has rings. Scientists believe the rings are very old, since they are extremely hard to see. The Voyager 2 space probe flew by Neptune in 1989 and discovered 6 of its moons.
Pluto. Pluto is the smallest planet in the solar system. It is so small, in fact, that some astronomers do not think it should be called a planet. Pluto is about the size of Earth's moon. It is also the coldest planet in the solar system. Pluto is so far away from Earth that scientists do not know very much about it. It is the only planet that has not been visited by a space probe. Still, astronomers have discovered that Pluto is a double planet. Its moon, Charon, is half its size.
Mercury.
Moon. How would you like to take a trip to the moon? The moon is the first place outside the Earth that humans have visited. It takes 3 days to travel the 238,857 miles, 384,403 kilometers from the Earth to the moon.
The first person on the moon was the American astronaut Neil Armstrong. He, Edwin Aldrin, and Michael Collins flew in the Apollo 11 space shuttle to the moon in July of 1969.
How big is the moon? The moon looks big because it is close to the Earth. The moon is actually small. It is about 2,160 miles, 3,478 kilometers wide. That's about the distance from San Francisco, California to Cleveland, Ohio.
If aliens lived on a planet behind the moon, they would get to see something we do not, the backside of the moon. The moon always keeps the same side pointed toward the Earth. The moon's surface. People talk about the man in the moon, but actually there isn't a single living thing on the moon. The moon has no atmosphere to keep the temperature constant like the Earth's atmosphere does. There's no water on the moon, so neither plants nor animals can survive there.
The dark spots on the moon were once thought to be seas. They are actually plains created by lava. One of the most well-known seas is called the Sea of Tranquility. There is even a lava plain called the Ocean of Storms.
The moon's surface is covered by more than 30 trillion craters. Most of these craters were formed when meteorites hit the moon. A few were formed when volcanoes erupted on the moon. Craters range from 1 foot, 4.7 centimeters wide, to more than 700 miles, 1,100 kilometers wide.
Just like the Earth, the moon has mountains. They may have formed when the edges of large craters broke or wore down. The tallest mountains on the moon are about as tall as the highest mountains on Earth.
Moonlight. You may think the moon changes its shape, but it doesn't. What you see in the sky at night is a phase of the moon. The moon doesn't give off light of its own. It reflects light from the sun. As the moon travels around the Earth, you see different amounts of its sunlit face.
When the moon is directly between the sun and the Earth, it is invisible. The sun is shining only on the other side of the moon. An invisible moon is called a new moon.
When just the first slice of the moon is visible, it is called a crescent moon.
When the entire right side of the moon is visible, it is called a first quarter half moon.
A waxing gibbous moon has only the very left side still invisible. When the Earth is directly between the moon and the sun, you see a full moon. The whole front side of the moon is reflecting light.
After the full moon has passed, the right side of the moon begins to disappear. This is called a waning gibbous moon.
The last quarter of the moon is also called a half moon. In this phase, the right side is invisible instead of the left.
When the last slice of the moon is visible on the left side, it is called an old moon. The moon is old because it's at the end of its circle around the Earth. The moon circles the Earth approximately once a month, or every 27 days.
Other moons. Earth's moon is not unique. There are more than 60 moons in our solar system. Nearly all of them circle the giant outer planets and are made of ice and rock. The largest planet, Jupiter, has at least 16 moons. 3 of them are larger than Earth's moon. Mercury has no moons.
Venus has no moons.
Mars has 2 moons.
Earth has 1 moon.
Jupiter has at least 16 moons.
Saturn has at least 18 moons.
Uranus has 15 moons. Neptune has 8 moons.
Pluto has 1 moon.
Formation. There are many theories about how the moon formed. Some scientists think that the moon was once a piece of the Earth. Most others believe that the moon and Earth formed from the same cloud of gas and dust about 4.5 billion years ago.
According to the escape theory, the moon is a piece of the Earth that was pulled away by the gravity of the sun. The dust cloud theory says that the moon and Earth formed at the same time. The formation of our sun left clouds of gas and dust that may have formed the planets and moons in our solar system. Comets and meteors. A comet is a ball of frozen gas and dust that travels around the sun. A comet is one of the largest objects in our solar system, but it contains almost no matter. A comet contains less than a billionth of the mass of the Earth.
A comet can have 2 tails, a dust tail and a gas tail. These tails always point away from the sun and can be almost 100 million miles, 161 million kilometers, long.
A huge hydrogen cloud surrounds the comet's head. This cloud can be 1,000,000 miles across. The cloud is invisible because it gives off ultraviolet light, which the human eye can't see.
The head of a comet is round. The nucleus lies at the center of the head. It is made of ice and dust, like a dirty snowball. The nucleus can be a couple of miles across.
The comet's nucleus is surrounded by a coma. The coma is made of gases released from the nucleus by the sun's heat. The coma can be 60,000 miles, 100,000 kilometers across. It shines brightly as it reflects the sunlight.
Around and around. Comets come from the Oort comet cloud that surrounds our solar system. They are visible from Earth when they circle close to the sun. A comet may circle the sun in as little as 3.3 years, or it may take more than 500,000 years to complete its orbit.
One of the most famous comets is Halley's Comet. In 1705, an English astronomer named Edmund Halley discovered that comets appear regularly. He determined that Halley's Comet appears every 74 to 79 years. It last appeared in 1986.
Meteoroids and meteors. Meteoroids are chunks of matter, pieces of comets and minor planets called asteroids that move through space. They come in all sizes. Meteoroids that come close to Earth usually burn up in the atmosphere. Shooting stars are actually meteors, meteoroids that burn and give off light as they travel through the Earth's atmosphere.
On a dark night, you can see a few meteors every hour. You can sometimes hear the burning of really bright meteors called fireballs. At certain times of year, the Earth passes through a meteor shower. During a meteor shower, you can sometimes see several meteors a minute.
Meteorites. Some meteoroids manage to survive their trip through the Earth's atmosphere. They hit the Earth as meteorites. Much of human knowledge about the solar system comes from studying meteorites.
Meteorites fall all over the world. They have even hit houses. The most recent large meteorite made this crater in Arizona about 25,000 years ago. Other large craters have been found at the bottom of Hudson Bay in Canada and under the ice in Antarctica. Meteorites are like heavy stones. They contain iron, nickel, and silicates. Scientists use meteorites to figure out what the solar system is made of.
Weather.
Atmosphere. A newborn baby is wrapped in a blanket to keep it warm and safe. The Earth is wrapped in its own security blanket, the atmosphere.
The atmosphere forms a very narrow band around the Earth. Compared to the size of the Earth, this band is about as thick as the skin around an orange. About 80% of the atmosphere is nitrogen gas. Most of the other 20% is oxygen gas. A small part of the atmosphere is water vapor, carbon dioxide, other gases, and tiny solids like dust and pollen.
Living and breathing. Without the atmosphere, it would be impossible to live on Earth. The atmosphere contains the air you breathe. It also protects plants and animals from the sun's dangerous rays and from the cold of outer space. The atmosphere contains a thin layer of gas called ozone. Ozone is a form of oxygen that traps harmful ultraviolet rays from the sun. Without the ozone layer, these rays would reach the ground and injure both plants and animals. This map shows the levels of ozone in the Earth's atmosphere during September 1991. Areas colored red have the most ozone. Areas colored purple have the least. The ozone level in the white area is unknown. Every year, holes form in the ozone layer above Antarctica and the Arctic Ocean. The holes are caused by chemicals called chlorofluorocarbons, CFCs, that destroy ozone. CFCs were once used to make things like spray paint and hairspray shoot out of their cans. But today, this use of CFCs is against the law.
Gravity. You probably know that gravity keeps you on the ground, but did you know that the atmosphere is also held in place by the Earth's gravity?
Have you ever noticed that you run out of breath more quickly at the top of a mountain than at the seashore? The air at the top of Mount Everest has only 1/3 as many molecules per square inch as the air at sea level. That makes it much harder to breathe. Mountain climbers must carry an air supply when they climb to the peak.
The Earth's gravitational pull exerts more than 14 pounds of pressure on every square inch of air at sea level. That means over 10 tons, 0.9 metric tons of air is weighing down your body. You don't feel this pressure because the cells of your body push outward with equal force. You do feel a change in pressure, however, when you climb much higher than sea level. The change in pressure makes your ears pop. Why don't the windows in airplanes open? Many airplanes fly at heights where there is not enough oxygen in the air for people to breathe. The airplanes are sealed and have air pumped into them. The force of gravity pulls everything, including the atmosphere, toward the center of the Earth. The pull is strongest near the Earth's surface, so that's where most of the molecules in the atmosphere are. 3/4 of the molecules in the Earth's atmosphere are packed into the 35,000 feet, 10,700 meters, right above the planet's surface. The force of gravity.
Layers of the atmosphere. The atmosphere is divided into several layers that spread out about 400 miles, 640 kilometers above the Earth.
Exosphere. There is no definite upper limit to the atmosphere. The last layer before outer space is called the exosphere. It hardly contains any air at all. Thermosphere. A layer of very thin air called the thermosphere extends from 50 to 300 miles, 80 to 480 kilometers above the ground. It holds the ionosphere, layers of electrically charged particles. Radio waves can be bounced off these particles and around the world.
Mesosphere. The mesosphere stretches from 30 to 50 miles, 50 to 80 kilometers, above the Earth. If meteors fall into this layer, they burn up, and you see them as shooting stars.
Stratosphere. The stratosphere extends from 7 to 30 miles, 11 to 50 kilometers up. It is a very calm region of the atmosphere. Airplanes fly in the stratosphere to avoid the winds and weather lower down. The ozone layer also lies in the stratosphere.
Troposphere. The troposphere is the atmosphere's narrowest layer, but it contains most of the atmosphere's gas. The troposphere reaches about 7 miles, 11 kilometers above the ground, but this varies around the globe and from season to season. Most weather occurs in the troposphere.
Colors in the sky. Have you ever wondered what makes the sky blue? When rays of light travel through the atmosphere, they hit gas molecules, pollen, dust, and other tiny particles. This causes the rays to scatter in all directions. Some colors of light are scattered more than others.
At sunset and sunrise, the sun is below the horizon. The light travels through more of the atmosphere before you see it. The blue light is scattered so much that it is absorbed or soaked up by the atmosphere. Only red light reaches you, so the sky looks red.
The atmosphere scatters mainly blue light. This is why the sky looks blue on a clear day. The sky looks gray when all colors of light are scattered. For example, when the sky is full of clouds or smoke.
Other atmospheres. Earth isn't the only planet with an atmosphere. Other planets have atmospheres too, but they are very different from the atmosphere around the Earth. This is a picture of Neptune. Its atmosphere is mainly methane gas. Jupiter and Saturn have thick, cloudy atmospheres of hydrogen and other gases. None of these planets can support life. Climates. What is it like outside where you...
3, 2, 1.
Earth. Whether you live in a big apartment...
What's up? Can I help? Stand by. I'll connect you to your program. Explorapedia. Stand by. I'll connect you to your program. Which settings do you want to change? Which sounds do you want to turn on or off? Wisecrackers is the game, and cracking the queg is the aim. Here's how we play. Your first question will show up in the question egg. That's the queg to those in the know. Your job is to find the answer. First, click the ship's window to go to a scene. Then find the topic where you think you'll get the answer. Read the topic. When you found the answer, click Got It on the queg. If you're in the right place, you'll get your next question. If you get stuck, you can always ask the queg for a hint.